We come in peace, Earthlings. We have commandeered this YouTube channel, as you call it, in order to educate you with our incredible Type 2 civilization technology.
Object-oriented programming, fundamental concepts.
Yes, this is something that you Earthlings need to know in order to be prepared for our incoming invasion.
We will not hesitate.
This is the table of contents, but you can read that in your own time. Puny mortals. Earthlings.
You may read the slides on your own time, as they will be uploaded after the invasion.
Fundamental principles of OOP, object-oriented programming.
Inheritance. Inherit members from parent class.
Abstraction. Define and execute abstract actions.
Encapsulation. Hide the internals of a class.
Polymorphism. Access a class through its parent interface.
Inheritance. Imagine that you have some sort of tree, as if there are parents and children. For example, an animal and a plant are both a part of the kingdom. We assembled this graph to help your earthling minds understand the concepts of inheritance by using things that are part of your human culture, such as armadillos and dandelions.
We do not have those on planet Zeeble.
We have armadillos, but they are green.
Greenadillos.
In this example, the dandelion is a child of the plant, which is part of the kingdom. We assumed that your civilization may be past the era of monarchies. It seems like you still have much to learn.
Classes and interfaces. This is a fundamental aspect of OOP, object-oriented programming. Classes define attributes and behavior, fields, properties, methods, etc. That is a acronym for Latin. We have studied your language, Earthlings. Methods contain code for execution. Interfaces define a set of operations. Empty methods and properties left to be implemented later. With a class, you can have fields and properties that can be inherited by other subclasses or superclasses. Have methods and properties drawn from them. Interfaces, however, define a set of operations that can be shared by classes that implement them.
Inheritance allows the child classes to inherit the characteristics of the existing parent class, such as attributes and operations. Attributes are just a fancy word for fields and properties, as your human minds cannot grasp too many concepts at once. Operations are like methods. Child classes may extend the parent class. They may add new fields and methods, or redefine existing ones from the parent class. A class can implement an interface by providing implementation for all of its methods.
This is terminology for inheritance. A derived class inherits from a base class or parent class, also known as a subclass inheriting from a superclass. A class implements the interface, and a derived interface implements a base interface.
Inheritance has a lot of benefits. Extensibility, reusability. It provides abstraction and eliminates redundant code. We have advanced so much as a civilization because we have implemented these concepts not only into our programming, but into our lives. You may use inheritance for building is-a relationships. For example, dog is an animal because dogs on the planet Earth are kinds of animals. This is different from our homeworld, where they are not. Don't use it to build has-a relationships. Dog has a name. Dog is not a kind of name on planet Earth.
But it could be on planet Zeeble. It follows our linguistic morphology. Another example of an is-a relationship is alien is a superior being to Earthlings. This is a diagram of inheritance. In your strange economic system, an employee is a type of person. It is derived from the do not have employees, so this concept is foreign to us. If we got it wrong, you can let us know after the invasion.
I do see one issue here. Employee does have a salary, but student is missing. Student debt. Ha 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 ha
I am getting a phone call. Sorry about that. Let us resume.
Inheritance leads to a hierarchy of classes and or interfaces in an application. Using one of your primitive humanoid concepts of games, we have devised this flowchart of what such a hierarchy would look like. For example, Minesweeper is a single-player game, which is a game. Solitaire, if you play it as humans do, is a single-player game, which is a child of the game. A chess game is a board game, which is a multiple-player game, which is a game. Backgammon is a board game, which is a multiple players game, which is a game.
Humans, if there is a backgammon, why is there no frontgammon? Ha 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 ha. Specifically, inheritance in the .NET framework for Microsoft, a class can inherit only one base class. In some programming languages, like the advanced ones we have on Planet Zebo, there is a concept called multiple inheritance. In .NET, a class can inherit only one base class. Idle exception, in this example, derives from system exception, which is derived from exception.
However, a class can implement several interfaces, which is .NET's form of multiple inheritance. For example, a list of a type implements the interface iList, iCollection, and iEnumerable, because it is a list, a collection, and an enumerable, and should implement the fields and methods that those interfaces supply. Of course, the syntax here uses the humanoid concept of generics, which, don't fret, we as well have not found a solution to.
How does one define inheritance? While writing it, you must specify the name of the base class after the derived class. We can form this with a colon, not the body part that you humanoids have, but the punctuation character found on your QWERTY keyboards. I guess also other keyboard types.
I don't think that is an appropriate joke to make, as we are trying to be educational.
I apologize. In the constructor of the derived class, we use the keyword base to invoke the constructor of the base class.
This is different from our concept of bases.
All your base are belong to us.
I meant base sphere.
Alien Ruth was a hero.
A simple example of inheritance in the language .NET or C#. We don't really understand the difference. Some humanoid concepts are unable to be processed by us. This is an example of a class that does not inherit anything. This is a base class. A mammal implements an age, and it has a method for sleep. An example of a class that inherits the class mammal is a dog, which has an extra property for breed, has a constructor that is different from the base class's constructor, yet still uses it, and a new method called wagtail.
Just to dispel rumors, we aliens do not wag our tails. We are very stupid. This is a cultural exchange slide. As you can see, we have a creature, an animal, as you Earthlings call it, from Planet Sequel. This is called a goingle. Say hello to the goingle.
Hello, Goingle. You are looking rather appreciative today. Access modifiers in C# are a way to prevent certain things to be accessed. Public makes access not be restricted. Private restricts the access to the containing type. Protected limits access to the containing type and any types derived from it. So for example, the differences between private and protected are that if you have a private field in mammal, dog may not access that field. Yet if that field is protected in mammal, dog may access it. Internal limits the access to the current assembly. That is similar to a package in other languages. A protected internal limits access to the current assembly or package or types derived from the containing class.
Here is an example. For this creature class, its name is protected, which is gettable by any derived classes, but not settable by anything but this creature. Its talk method is private, and its walk method is protected. The mammal, which is a subclass of creature, cannot invoke the private talk method. It can read the name as it is protected, but it cannot set it.
That is good, because if dogs could talk on planet Earth, they might not be as friendly as dogs talking on planet Zebel.
This further subclass, dog, a mammal, has a public string, breed, for its breed, and cannot invoke base talk as before, as it is still private.
The class inheritance and accessibility is an example class which has a main function. This class inheritance and accessibility uses these concepts. It creates a dog which has the age of 6 in the breed of Labrador, which goes into a variable Joe. It then prints this out to the humanoid concept of consoles. You cannot call Joe.walk because it is protected and cannot be invoked. You cannot call Joe.talk because that is private and cannot be invoked. You cannot set Joe.name and you cannot set Joe.breed. This is an example of all of the fields and methods being restricted in one way or another. This personal computing device seemed to have talked a little too much.
In C#, structures, which are a data type, cannot be inherited. As discussed previous, there is no multiple inheritance, only multiple implementation of interfaces. Instance and static constructors are not inherited. Inherited is a transitive relation. If C is derived from B, and B is derived from A, then C inherits A as well. If you think about the flow charts from earlier, where a dog inherits from a mammal, which inherits from a creature, the dog has aspects if derived from both creature and mammal.
Important features of inheritance. A derived class extends its base class. It can add new members but cannot remove derived ones. Declaring new members with the same name or signature hides the inherited ones. This is often known as shadowing. A class can declare virtual methods and properties in the language C#. Derived classes can override the implementation of these members. For example, object.equals is a virtual method. This is to allow any object to have custom equalities. For example, if you were to compare humanoid creatures to Zeblians, you will find that they are not the same, and one of which are much, much more superior.
Abstraction. You can see this marvelous Zeblian hand on the slide. They are not usually blue.
I think you are letting your personal biases affect our educational display of knowledge. They are not normally blue, but it is okay that they are blue.
I was ignorant. I apologize. Abstraction. Abstraction means ignoring irrelevant features, properties, or functions and emphasizing the relevant ones, as in relevant to the given project. Abstraction is a way of managing complexity in your project, methods, objects, and classes.
Abstraction is something we do every day. Looking at an object, we see those things about it that have meaning to us. We abstract the properties of the object and keep only what we need. For example, students get name, but not color of eyes. And do not worry, even though it was not in our example, they do get a lot of student debt. It allows us to represent a complex reality in terms of a simplified model. Abstraction highlights the properties of an entity that we need and hides the others.
Abstraction in .NET. In .NET, you can achieve abstraction through several ways: abstract classes, interfaces, and inheritance.
For example, control would have a click method. Button base would have a color property. A button, a radio button, and a checkbox all inherit button base, which also inherits the click method from control.
This allows one in a project to share features when necessary and hide features when not relevant to a current, in this case, button.
It also helps split up the ownership of certain properties. For example, as control contains click, every single interactable component of a UI does not need to implement a click method, but instead share the same one coming from control.
In .NET, here is an example of abstraction. Near the bottom, a Windows, which is your strange operating system, or at least one of them, has button as part of forms, which inherits from button base, which inherits from control, which inherits from component, which inherits from Marshall by ref object, which inherits from the base universal object. An interface is a set of operations in a given object form. It can also be referred to as a contract for supplying a set of operations. It defines abstract behavior that can be inherited by different objects.
The way that I personally enjoy describing interfaces is that it is like a promise. With an interface, you promise to implement these methods or these fields in your class.
You should not have to know anything about what is in the implementation of an interface in order to be able to use it.
Abstract classes are special classes defined with the keyword abstract. It is like a mix between a class and an interface. It can be partially implemented or fully unimplemented. Methods that are not implemented are declared abstract and are left empty, but they cannot be instantiated. Child classes should implement abstract methods or declare them as abstract.
Abstract data types, ADT, are data types defined by a set of operations.
For example, a list interface promises that it will have the methods add, remove, and clear. These three methods are all implemented by linked list and list, which is why you may instantiate linked list and list.
Inheritance hierarchies. Using inheritance, we can create inheritance hierarchies, easily represented by UML class diagrams. UML stands for Unified Model Language, which is funny because it is only unified on your little blue marble, as you call it.
We use something quite similar, except we chose a better acronym.
In UML, similar to ZML, classes are represented by rectangles containing their methods and data. Relations between classes are shown as arrows. Closed triangle arrow means inheritance. Other arrows have different kinds of associations. In ZML, instead of a rectangle, we use a key.
This is an example of a UML class diagram. In UML, you can see one of the pitfalls of such a simplified construction, where the arrows must overlap in certain places. In ZML, our diagrams are not only three-dimensional, but four. This begins the part of the presentation about encapsulation. In the diagram, you may see a young zeblin which is undergoing hatching. They are encapsulated within their birthing shell. This is, of course, a simplified diagram, as there is no icky birthing goop.
Encapsulation hides the implementation details. A class announces some operations available for its clients, which is described as its public interfaces. All data members of a class should be hidden, except for when there is a really good reason to make them public, which is usually never. In OOP, object-oriented programming, these can be accessed via properties read-only and read-write. No interface members should be hidden. After all, they are to be accessed.
For example, in OOP, you generally want data fields to be private. Constructors and accessors are defined, getters and setters. In the language C#, they have implemented some, as humanoids call it, syntactic stevia for getters and setters, where the language automatically constructs getters and setters for you. But in a different language, such as Java, you must implement methods for getters and setters by hand.
We young planet people first became aware of Java because of this strange, odd creature. In .NET, C#, fields are always declared private. They are accessed through properties in read-only or read-write mode. Constructors are almost always declared public. Interface methods are always public, but not explicitly declared, it is implied. Non-interface methods are declared private or protected.
The benefits of encapsulation are plentiful. It ensures that structural changes remain local. Changing the class internals will not affect any code outside of the class. Changing methods implementation does not reflect the clients using them. Encapsulation allows adding some logic when accessing clients' data. For example, validation on modifying a property value. Hiding implementation details reduces complexity, therefore, maintenance is easier.
Next is polymorphism. In the lower right, you can see an advanced member of the alien invasion, the polymorph goo. This contained zepospores.
Polymorphism is the ability to take more than one form, objects having more than one type. A class can be used through its parent interface, and a child class may override some of the behaviors of the parent class. Polymorphism allows abstract operations to be defined and used. Abstract operations are defined in the base class's interface and implemented in the child classes. They are declared as abstract or virtual.
Why would one want to handle an object as an object of its base type? Because this allows you to invoke abstract operations upon the object. Can mix different related types in the same collection. For example, you could have a list of creatures with both humanoids and zeblings, although frankly, mixing the two is inevitable following the invasion. Another example would be in a list of just objects. Another use of this feature is passing a specific object to a method that expects a generic type. Finally, you can use this to declare a more generic field, which will be initialized and specialized after its declaration.
Virtual methods are methods that can be used in the same way on instances of base and derived classes, but its implementation is different. A method is said to be virtual when it is declared as virtual. Methods that are declared as virtual in a base class can be overridden using the keyword override in the derived class. This is different from Java. In Java, it is quite the opposite, where most methods are virtual implicitly, and you must declare a method as final, where it may not be overridden.
The override modifier. In C#, using override, you can modify a method or proper. An override method provides a new implementation of a member inherited from a base class. You cannot override a non-virtual or static method. That is the whole point of the virtual keyword. The overridden base method must be virtual, abstract, or override.
So how does polymorphism work? Polymorphism ensures that the appropriate method of the subclass is called through its base class's interface. Polymorphism is implemented using a technique called late method binding. The exact method to be called is determined at runtime, just before performing the call. This is applied for all abstract or virtual methods. A note: late binding is slower than normal binding, also known as early binding.
Here is an example of polymorphism. The abstract class figure has the abstract method count surface. The concrete classes square and circle, which are both figures, both override count surface. For squares, it returns size times size, as one would expect. But for circles, it uses some strange thing called pi. We are not sure what that is on Planet Zeeble. Regardless, if you call a method that is expecting a figure and within it calls count surface, supplying either a square or circle will still work.
I do not understand how humanoid delicacies apply to object-oriented programming, but I will assume it is one of those metaphors.
I'm hoping it is pi and not p.
This is the implementation behind the previous example, where you can see figure is abstract and implements the abstract calc surface. We will not be going over the live demo of polymorphism, but we wanted to show the polymorphic forms of some Earth creatures that we have improved on Planet Zeeble.
They are now much closer to the native fauna of Planet Zeeble. Much better now. Our last topic, cohesion and coupling. Cohesion describes how closely all the routines in a class or all the code in a routine support a central purpose. Cohesion must be strong. Well-defined abstractions keep cohesion strong. Classes must contain strongly related functionality and aim for a single purpose. Cohesion is a useful tool for managing complexity.
Here are some marvelous examples. In the bottom left, you may see Zeeblian spaghetti. In the bottom right, you may see humanoid spaghetti.
Humanoid spaghetti looks a little bit like Zeebleworms. Strong cohesion. The math class has the methods sine, cosine, arcsine, square root, power, exponent, math.pi, that pi thing again, math.e. We also have e on Planet Zeeble, but it's z. Euler's number. All of these methods are related to the concept of mathematics.
An example of bad cohesion is this class, Magic, which has these methods: print document, send email, and calculate distance between points. None of these are related, and quite frankly, upsetting to look at. Another example is magicclass.makepizza, magicclass.withdraw money, and magicclass.opendatabase connection. Fat Pepperoni was the name of my Zeeblian dog in Zeeble School.
Rest in pieces. Hit by a Zabuka and exploded.
Fat Pepperoni is now many pepperoni.
Coupling describes how tightly a class or routine is related to other classes or routines. Coupling must be kept loose. Modules must depend little on each other. All classes and routines must have small, direct, visible, and flexible relations to other classes and routines. One module must be easily used by other modules. This pairs nicely with the concept of encapsulation.
Loose coupling. A real humanoid example of loose coupling is that you can easily replace old hard drives, and then you can place a hard drive into another motherboard. I do not find that very faithful, yet it is allowed. Tight coupling. Where is the video adapter? Can you change the video controller? This looks like a Zeeblian smorgasbord.
It is so simple, it must be for the freshly hatched. Here is an example of loose coupling. The report class, printer class, and program class. The report class loads from and saves from files, whereas the printer class has the print method, which requires a report. The main method in the program class creates a report, loads its contents from a file, and then prints it.
This is an example of tight coupling. math params has static fields, operand and result. Math-util has a static method square root, which calculates the square root and then sets the math param's result to the square root of the math param's operand. The main class sets the operand to a number, 64, and then calls the square root function and prints the result. This is wildly unnecessary to rely on many statics and will make expanding harder. Spaghetti code. It is a combination of bad cohesion and tight coupling. The report class has print, initialize printer, load printer driver, save report, and set printer. The printer class implements set file name, load report, and check report. You can see that the printer class contains methods which should belong to report, and report contains methods which should be inside printer. This means both classes are coupled very tightly and have little to no cohesion.
They are jumbled together like zebra worms. In summary, OOP, Object-Oriented Programming, fundamental principles are inheritance, encapsulation, abstraction, and polymorphism.
Inheritance allows inheriting members from another class.
Abstraction and encapsulation hide internal data and allow working through abstract interfaces.
Polymorphism allows working with objects through their parent interface and invoke abstract actions.
Strong cohesion and loose coupling allow you to avoid spaghetti code.
Any questions may be posted in our public comment section.
We will be checking it for the next 48 hours or so. However, once the invasion begins, we cannot guarantee any questions will be answered. Be prepared, Earthlings.
I will clarify that the so-called hours are the human concept of hours and not the Zeblian concept of hours, because 48 hours in Zebel time is the equivalent to 347 Earthling years. Thank you for listening to our presentation. We know you may not be as intellectual as us, but we are hoping that with this knowledge you will take it to heart and maybe the invasion will not be as deadly as we are expecting.